Okay, this is the last section in chapter 2. Of course, that means test is coming up, doesn't it? So good and bad. Directly proportional, or direct variation, as it's sometimes referred to. Direct variation is as one amount increases, another amount increases at that same rate. For example, if you're paid 20 bucks an hour, how much you earn is directly proportional to how many hours you work. You work more hours, you get more pay. That's a direct proportion. Okay, for example, if y is directly proportional to x, if we know that, and when x is 3, y is 15, we want to know that constant. Remember it said it's increasing at a constant rate. What is that rate? Okay, when I know that y is directly proportional to x, then I know that y equals some number k times x. Okay, as for example, if I get paid $9.50 an hour, then if x is the number of hours I work and y is how much I get paid, y is 950x. My hours, how as my hours increase, my pay increases by a constant rate of 9.5 per hour, right? Okay, so that's what we're looking for, that number k, that they call it a constant of proportionality, okay, or a constant of variation, depending on what word they're using. Well, we already know that, one x and y point, so I'm just going to put them in. They said that y was 15 when x was 3. Well, that tells me that k is 5. So now I know my direct proportion is y equals 5 times x. X and y are directly related by a constant of 5. Okay, that's the constant of proportionality. All right. Inverse proportion is different. As one value decreases, the other value increases. They're inversely proportional. Okay, the further back, the bigger my distance is, the smaller my brightness is. Okay, light and distance, the further we are away from light, so our distance is getting greater, the less bright it is. Okay, so that's an inverse proportion. The way we write that, instead of y equals k times x, it's y equals k over x. All right, y equals k over x. We have a rational function for an inverse proportion. For example, people can paint a fence in 3 hours. How long will it take 6 people to paint it? Well, the more people, the less hours it's going to take, right? Unless, of course, so that doesn't always work because kids start fooling around, right? And then it might take longer. But as the number of people goes up, the paint time goes down. As the number of people goes down, the paint time goes up. All right, so 4 people can paint a fence in 3 hours. So we might write 4 people can paint the fence in 3 hours. They're inversely proportional, so 4 equals some constant over 3. My constant ends up being, let's see, multiply both sides by 3, 12. So the number of people equals 12 over the number of hours. So how long will it take 6 people to paint it? 6 equals 12 over what? Well, that would be 2. We could write 6x equals 12 and write x equals 2 if we wanted to go the whole way. So it's going to take 2 hours is all for 6 people to paint it. All right, so try this one. Pause me for a sec. Wait a second. Sorry. I was thinking you could pause me for a minute and take some of these and think about which side of the fence it would go on, okay? Is it a direct proportion or is it an inverse proportion? The length of a car in inches, the length of the same car in feet. The temperature in degrees Celsius, the temperature at the same time and place in degrees Fahrenheit. the price for each person sharing a $20 pizza, the number of hungry people, etc. Okay, go ahead and pause me and try that. Okay, hopefully you got this. The length of the car in inches and the length of the same car in feet. As the length in inches goes up, so does the feet. As the temperature goes up in Celsius, it goes up in Fahrenheit. The area, as long as the height is just 10, let's say, then as the area goes up, the base must be going up. Pounds or kilograms, as the weight goes up, so is the kilogram weight. And the time in seconds or the time in minutes, always going up. Here, though, okay, as the number of people go up, the price per person is going down. As the length, okay, we're saying the area is 40 for her closet. 40 is length times width. So as the length and width are inversely proportional, right? The width would be 40 over the length. Like if it only is going to be 40 for the area, so that's different here. Here I didn't know the area. Here I know the area is 40. As if I only have $50, the number of gallons I can buy goes down as the price per gallon goes up. Okay, so just an idea. Let's try some of these. If y is directly proportional to z, as soon as I see directly proportional, I write this down. Y equals some constant times z. Okay, here h varies inversely as q. I'm going to write k over q. Okay, y is 6 when z is the square root of 12. What is y? Well, I don't know. Let me figure this out. K is 6 over the square root of 12. I don't like square root of 12. 12 is 4 times 3. So let's write that as 2 root 3. Okay. 12 is 4 times 3. Square root of 4 is 2. We'll bring that out. 6 divided by 2 is what? 3. So K is 3 over the square root of 3. Great. So now I know my formula. Y equals 3 over the square root of 3 times z. We want to know what is y when z is the square root of 75. Well, it's going to be 3 times, let's see, square root of 75 divided by square root of 3. That's square root of 25, which is 5. My answer is 15. Here, h varies inversely as q. H is 0.03 when q is 0.01. So I am going to multiply 0.03 times 0.01. So move that over a few more spots. That's what K is. I'm going to multiply those together. So now I know that H is 0.0003 over Q. It says, what's H when Q is 0.05? It's 0.0003 over 0.05. So H, oopsies, H equals 0.006. Okay, those are your typical variation problems. Now, joint variation happens. It's basically direct variation with 2 or more variables. For example, the volume of a cylinder varies jointly. If they say jointly, that means directly, with the square of the radius. So the volume varies jointly. So it's going to be K times the square of the radius and the height. Okay, so radius squared times height. When the radius is 3 and the height is 6, oops, the volume is 36 pi. So we'll put 36 pi right here. Find the volume when the radius is 4 and the height is 5. Well, I can't do that unless I know what K is. So I get 36 pi equals, what's 3 squared? 9 times 6 is the height. Wait, the radius is 3 and the height is 6. Yes. 9 times 6, so 54K. I'm going to divide by 54. Okay, so K equals 36 divided by 9. What do we get? 4 pi over, no, divided by 18. We get 2 pi over 3 is what K is. So we have 2 pi over 3 r squared h. So now I can find the volume when the radius is 4 and the height is 5. We just plug that all in. What's that? 16 times 5 is 80 times 2 pi. 8 times 160 pi over 3. Cubic, whatever. Inches, feet. Okay. So again, it's just kind of just one, the main point is that when it's jointly, it's directly, okay, in that we don't divide, we take K times 2 variables instead of just 1. Okay. If J is jointly proportional to G and V, then I know that J equals K times GV. If J is the square root of 3, when G is the square root of 2 and V is the square root of 8, then I have square root of 3 equals K times square root of 16. Square root of 3 equals 4K. So K is the square root of 3 over 4. So now I know the formula. I find K first so that I can write the formula. Square root of 3 over 4 GV. So what is J when G is square root of 6 and V is 8? So J equals, what's that, square root of 18. And then 8 divided by 4 is 2. So we have 2 square roots of 18. 18 is 9 times 2. Square root of 9 is 3. 3 times 2 is 6. Square roots of 2. Okay, that was kind of fast, but the point, again, isn't so much the square roots and the multiplying and the simplifying as just getting the formula. All right. A stone's dropped from a top of a tower. The distance it falls is proportional to the square of the time of the fall. Sometimes they just say proportional, and we assume directly proportional. Okay? It's proportional to the square of the time of the fall. So the distance equals K t squared, let's say, for D is distance and T is time. The stone falls 19.6 meters after 2 seconds. So 19.6 equals 4K. K equals 19.6 over 4. You can either do that on your calculator if you want, or just write 19.6 over 4. That's fine with me. It ends up being 4.9. Okay, so the distance equals 4.9 t squared. How far does it fall after 3 seconds? Now I can just say 4.9 times 3 squared. 4.9 times 9 is the final answer. It falls 44.1 feet. Okay, these are just some examples. A force varies inversely with the square of the distance from an object. When the distance is 6, the force is 144. So you'd find K, which is 144 times 36, 5,184, and then use that to figure out the force, 5,184, when the distance is 9. So it's 5,184 divided by 81. The force is 64. Okay. That should be it. Nope. Yes, that was it for inverse variation and then direct